Alrighty, let's take a look at this question. So, a blah blah blah, basically a car. I'm going to highlight a few things here. So, car has a highway fuel efficiency of approximately 3.2 gallons per 100 miles, and the cost of gasoline is $3.60 per gallon. We're going to need that information in a minute, so we highlighted it. Now, let's read the first part, 1A. The volume, and we're calling volume V in gallons, of fuel that can be written as a function of the distance d. So distance is in miles, and the variable is going to be d that represents that. Miles traveled. Complete the following for v in terms of d. Okay, so we are going to have like v equals, and then somewhere over here has to be a d. That's what it means by in terms of d. Now, if we look at volume, that's V, and distance traveled, the one thing they mentioned was 3.2 gallons, 3.2 gallons per 100 miles. Now, so it could be as simple as just 3.2 gallons per 100 miles times D. So let's kind of test it out. If we drove 100 miles, in other words, we put 100 miles in for D, then those two hundreds would cancel and the volume of gas used would be 3.2 gallons. So that actually works. So that looks like our formula. Now we don't need all those units in there, so we can write it as 3.2 over 100, although a decimal within a fraction, not really cool. So how about we change that to just simply divide that on the calculator and you get 0.0, let's see, move that over twice, so 0.032, and then D times D. There we go. Okay, so we've got volume in terms of D, and now we're going to look at the next one. So they want us to find the cost, C, so we're using the letter C for cost in dollars, of gasoline that can be written as a function of V, and remember V was volume, right? Well, in the initial part of the question, they told us cost of gasoline is $3.60 per gallon. So if cost equals $3.60 per gallon, if we multiply that by the number of gallons, so that would be volume, then the gallons would cancel, you'd end up with cost. So that kind of makes sense. Like if volume was, say, 1 gallon, then boop boop, 1 times 360, it would cost us $3.60. So that kind of works. Now we're going to drop all the units there and write it as an equation. So 3.6, you can write 60 if you want, or just 3.6 times V, volume. So cost in terms of V, we got that. Okay, now let's look at the final one, which is what they're leading up to, which is composition. So it says we can find the cost of gasoline in terms of distance traveled by combining these two functions. So you notice the variable in here is D, which is distance, and that was in this thing here. And C, of course, is cost, which was this one up here. So if we were to put this equation, like V, in for V here, then it would be in terms of D. See how if we replace V with this function, then cost would be in terms of D. So let's try that out. So it's sort of like going C of V of D, essentially. So we're subbing, well, they call it F at D, but I'm going to call it V at D. So you would take cost, and then we replace in here for V what V was equal to. So that means 3.60. Then we replace V with the first equation, 0.032D. And there we go. Okay, so let me just recap that so we understand what's going on. So we took V, which is basically 0.32D, and we replaced V in this equation, and that created C in terms of D. That's how we got that. All right, now we can simplify that a little bit. So I would probably multiply the 3.6 times 0.032, and so that you get 0.1152D. And you could write it in function notation if you want. You can write that as, instead of just C, you could write C of D, meaning C as a function of D. And there we go. That should be your final answer. I know that last part was a bit confusing, but essentially you're just scooping out the V from the second equation and replacing it with what V equaled from the first equation. Alrighty, hope that helped.